Hi, my name is Maya Galvin, and I will be presenting on two specific BIM applications. The first application that I will be discussing is disaster planning. So this application is when emergency responders can use real-time information provided from BAS and BIM systems to improve the efficiency of their response and minimize their safety risks. These programs can provide them with floor plans, equipment schematics, location information, um, and the combination of these two programs can provide them the most current information present for an emergency situation. They have two required resources for this application, which is the ability to manipulate 3D models and knowledge of building automation systems, or BAS. This application comes with several benefits as well as challenges. The benefits include that this provides police, fire, public safety, and first responders access to critical building information in real time. This can improve the effectiveness of their emergency response, and it can minimize their own personal safety risk while they are on site. This also comes with a few challenges, primarily the idea that they need an additional competency, which is the manipulation and understanding of these kind of dynamic and complex BIM and BAS systems. The decisions made can be based on the technology that they have. So if they're having a technological problem, it may impact the decisions that they make. In addition, the scale of the emergency may not allow ample time for an in-depth analysis of the situation and the programs, so they need to be really adept at handling these systems and be really well prepared to handle them in a time-sensitive situation. Next, we have a few project examples of the disaster planning application. The first is a BIM-based intelligent fire relief and disaster prevention system, which is located in Taiwan. This system effectively provides 3D visualization to support the assessment and planning of fire safety. It provides early detection and alarm responses to direct efficient evacuation and to facilitate fire rescue and control efforts in order to increase overall building safety and disaster response capabilities. The second project example is a BIM data utilized in multi-disaster relief in Korea. This study develops an integrated disaster data platform utilizing 3D BIM data with experts in earthquake, fire, and flooding fields to build a digital twin-type facility disaster management system that can be effectively addressed. The photo included is in regards to the first project example. On this slide, we have two more project examples. The first example is of a GIS system located in Indonesia, which was developed for volcanology and geological hazard mitigation. This region of the world is the Ring of Fire, so this is a essential issue for them. This system helps decision makers understand the scope of the damage and identify locations where people may be trapped or injured or require medical support and rescue. And lastly, our last example is of domestic facilities in the US that utilize CCTV for accurate situation reports. So CCTV is closed circuit television, which is essentially when management systems receive real-time data from on-site sensors, and they can respond to the situation through use of the proper firefighting facilities, which are all required for effective disaster management system. So that's all we have for disaster planning. Next, we'll move into our next application, which is design reviews in BIM systems. So the description of this is that it can showcase design and evaluate program requirements in really high detail. It allows the designers and anyone working on the project really to easily make changes to things like layout, sightlines, lighting, security, ergonomics, acoustics, textures, colors. etc., etc. So they can quickly analyze design alternatives as well and solve design and constructability issues on the spot. They use this system to resolve and modify designs without the time and cost of traditional construction mockups, which might include a physical model or drawings by hand. So some required resources for this is 3D model manipulation again, design review software, so being familiar with these kinds of softwares that will be utilized, and then also an interactive review space for the designers and the construction team and the engineers and um, anyone working on the project really to kind of interact and be able to review the project together. This application also comes with a number of benefits and challenges. For one, different design options and alternatives are easy to model and change in real time during the design review by end users or the owner. They can create shorter and more efficient design reviews, resolve conflicts in real time and receive instant feedback, preview space aesthetics and layout during design review in a virtual environment, efficiently evaluate effectiveness of design in meeting building program criteria and owners' needs. So essentially, it creates a platform for the designers and the end users to kind of negotiate the design and make sure that it meets all of the programmatic needs of the user. This also comes with some challenges, including that it requires aptitudes in building and reviewing these 3D modeling programs. So, in order to design on these, you need a specific skill set. There may be a client preference to a physical model, um, which also has its pros and cons. One of the main cons being that some of that feedback can't be established in real time, and it creates a little bit more of a difficult review process. And lastly, this platform may require more precise realism because the models are so detailed. So, in order to make sure that you're meeting the programmatic needs, you need to include a lot of details so the client can kind of understand what they're looking at. We have a number of additional project examples as well. So the first one is the Wisdom 101, which is located in Bangkok. This is a sustainable smart city that was designed, and they introduced the BIM technology gradually, and they started with the architects and structural engineers using the program Revit to develop and coordinate the designs. They extended the success by working with the contractors and suppliers during pre-construction, which helped reduce change orders and materials costs. So that's kind of another perk of using BIM technology in the design process, is that you don't have to make as many changes down the road, which can be a lot more expensive once you're working with real life materials. The second example that we'll be looking at is um, the Marquarrie University Incubator. So these architects worked closely with their consultants and contractor to a high degree of high design resolution through traditional means of meeting and hand sketching, but also through the use of BIM models. So this is another practice that is often utilized where they're kind of using a combination of both the hand drawing techniques as well as the BIM models. And this kind of goes back to that collaboration between the designers and all the other members of the team in order to make sure that you're creating a design that meets all of the needs of everyone involved. So we have two more project examples on this slide. The first is Casa Nova by Jewel Frost Architects. So you can see the high level of detail on the right side of the slide in that interior view. So this detail phase has been unique with its smooth dialogue-based cooperation between the architect, the contractors, the client, which created the right platform for formation of a new high-profile building. This is a good example of the level of detail that can go into these computer models. You can really kind of feel like you're in the space and make any adjustments that you want aesthetically before construction even takes place. And finally, we have the National Library of Sejong City by Samu Architects and Engineers. So in this project, BIM provided solutions to pre-construction simulations among various disciplines and manufacturing of unique panels and certain wall systems that was fundamental to the unique geometries of this project. So this is a unique situation because they actually used BIM to kind of solve some of these pre-construction problems that they knew that they were going to have. So they could use BIM to kind of look at these problems digitally before construction took place and figure out how these unique geometries would work together. So that's all that I have for the design review section. These are some of the resources that I used, and that's all that I have. So thank you for watching. I appreciate your time and feedback. Thank you.